Hello and welcome to another creative coding video. Today we're going to be looking again at repetition and loops. But before you say, we've already done that, there's a good reason for looking at it again. Now, before I start talking too much, let's dive straight into an example because it will give more meaning to the discussion. So on the screen you can see a row of circles. They start at x is 100 over here and they go all the way up to 700, and the jump is in steps of 100. Now we know how to do this with the repeat instruction. In fact, let's look at it now. So here I am logged into Open Processing as usual. I have my simple.js library set up somewhere here. There it is. And it's enabled in the setup section. And you can see the repeat instruction, which starts a counter at 100, goes up to 700, and increases in steps of 100. So it counts 100, 200, 300, 400, 500, 600, 700. And it calls a function which we've defined here, this function called blob, and passes that counter, and we've called it x, and it draws a circle x along, 300 down, size 50. So we've done this lots of times before, so this is all very familiar to us. If you need a reminder, do go back and have a look at those earlier videos which introduce repetition. Now this is really simple to use. I mean, this is really intuitive. We know we start at 100, we go up to 700, we go up in steps of 100. That's nice and easy. What I didn't tell you before is that this repeat instruction is part of the simple library which I've written to provide a very easy, intuitive way of repeating code. It's not actually part of this programming language, which is called JavaScript. Now, JavaScript is used a lot. It's one of the most popular programming languages. It's most used on the internet. You know, your web browser can run JavaScript, so interesting and rich websites will use JavaScript. Now, the loop in JavaScript isn't so straightforward, which is why I didn't introduce it much earlier. My experience was that many beginners and young learners just found it just too difficult. And that's the reason we've been using this simplified repeat instruction. And there's nothing wrong with that. It works, it's fine, it was good enough for our needs. But there are scenarios where repeat isn't going to kind of help us. We'll come to that in a little bit. So let's introduce the JavaScript's own way of doing repetition, which you'll find in JavaScript everywhere, because this simple library with its repeat isn't available everywhere else. Before I go further, I should say that what we've learnt using repeat, the idea of loop counters, the idea of nested loops with two counters, all that is still valid. And in fact, those ideas are transferable ideas to many languages, not just JavaScript, but Python, Java, C, C++, and many others. The concepts are the important thing, and they are still valid in those other programming languages. Okay, so the way JavaScript and many other languages actually do repetition is with what's sometimes called a for loop. So let's kind of write it and talk about what it means as we write it. So it starts with a for instruction. There's something that goes in the brackets which we'll fill in a minute. And there's a couple of curly brackets to kind of create a code section. Now you can guess that the repeated code goes in here. So let's write that. Repeated code. So that's a comment, so it doesn't get run. Now, what do we want to repeat? We want to repeat the circle instruction, which draws the circle X across, 300 down, size 50, just like we did with our blob function. You can see that this X has to come from somewhere, some kind of counter, and that's actually what this section of the for instruction, the for loop, does. By the way, for loop is another very common phrase for a code loop. People will often say for loop and they mean this. And while you're here, it's worth kind of knowing that it's not just JavaScript. The code for loops in Java, C, C++, and a few other languages is almost identical. I mean, you'll have to kind of look it up to see what the differences are, but they're more or less the same. And the reason it's historic, this kind of construct came from the very early days of programming with the C language, but that's ancient history now. Okay, so let's write some code which defines this counter. And the way we do it is we declare a variable. We say it starts at, say, 100. Then we say, actually I'll fill that middle bit in next, in a minute. So we start with a loop counter that starts, it's called X, starts at 100. We increase it by say 100, which is what we were doing before. So we can say X plus equals 100, which is another way of saying X equals X plus 100. It's just a bit shorter. This middle bit is the bit that confuses people, including very experienced programmers. It's a condition. It's a question that's asked. And the question, if the answer is true, then this code is run. If it is not true, then this loop finishes. So we continue repeating the loop as long as X is less than 800, or, as we said it in a different way, less than or equal to 700. So let that sink in. Let's say that again. This is a code that's being repeated, drawing a circle. This is the for loop, which creates a counter. We create it ourselves actually by saying var x. It doesn't do it for us. We say var x, create a variable x with value 100. At every repetition of the loop, it's increased by 100. And this loop continues as long as this question, the answer is true, this condition. So as long as X is less than or equal to 700, or X is less than 800, that loop will repeat. Now, that makes logical sense, but you can see why we didn't introduce it early on, because the repeat instruction is just so much easier. But it is worth at this late stage in the course seeing this, because you'll see lots of other people using it, and you'll need it when the simple library isn't available. So let's run this code and just check that it does what we expect. Yep, there you go. And let's just experiment just to kind of understand how the various parts work. So if we increased X by 50 every time, that's the counter increasing by 50. You can see that there's more of those circles because they're moving across by 50 instead of 100. So that works in a familiar way to our repeat instruction. Now the mistake that people make is again, as I said, around this middle kind of condition. So if they wanted something to go up to 700 like we did, we wanted, let's draw that picture again, up to 700, not 800 here. then we want it to draw the last circle at 700. And it's a common mistake is to say x is less than 700. When x is 600, this is true. When x is 700, this isn't true, because 700 is not less than 700. It's less than or equal to 700. So there's two ways of doing this. It's a matter of style, taste, choice. Some people like this because it's very clear that the last x will be 700. It's very clear. Some people prefer saying something like that, or even 701. Now, it's up to you, and sometimes one or the other will make more sense, but this is certainly kind of unambiguous. So that's it. This is the JavaScript loop, the C style loop, and you'll see it in many languages, and it's available in JavaScript even when you don't have the simple library to give you the repeat instruction. So that's great, and you can stop now if you like with this video and come back later, because this is the explanation of the for loop. We're going to carry on to talk about nested loops. So let me draw another picture to help us kind of visualize what we're talking about. Now, with a nested loop, we had two counters. We had one counter which might start counting from, say, 100 and going up in steps of 100 all the way up to, say, 700. That's a normal loop. With a nested loop, we had two counters. The first counter was the one we've just described, going from 100 up to 700 in steps of 100. But for each of these, we start a new counter. So when we are at 100, we can start a new counter, and we can say this counter goes from 100 up to 500 in steps of 100 again. And we can use that. We can use that to go down the canvas. We can say count from 100, 200, 300, 400, 500. Great, so that loop's done. That's done. And then we go back to the first counter and increase it to 200. And then we repeat this counter again, 100, 200, 300, 400, 500. That loop's done. We go back to our first counter, which is now increased to 300, and so on. And you can see how this can fill the canvas. Now, when we did the repeat instruction, we simply defined the two counters, where they started, where they ended, and the step size. Really easy. And we passed two parameters to the function, which were the two counters. Let's see what that looks like with this native for loop. Well, actually, it's just a loop within a loop. So what we can do is we can say for, so this is the code that's repeated for one counter, that one. Once we're inside, we simply create another for loop. We can say y equals 100. We can say y is less than or equal to 500, and we're saying that y is increased by 100 every time. And the code here is what's repeated. So what I will do, I will remove that, and I'll say circle x, y, 50. Can you see how the indentation, which is done automatically, and it's a good habit to keep it as well, and to do it yourself, helps us see the structure. So this is the main function that we've always used. This indentation is the first loop. Within that, the next indentation is the inside loop. So this starts at x100, it will count up to 700, but for every one of those steps it runs this all the way from 100 to 500. Let's check it does what we expect. Yep, exactly, that's exactly what we expected. And that's a nested loop, and you can see why the word nested loop now makes sense, because this is nested inside this. Great, we've now done nested loops with the native JavaScript loop. Have an experiment yourselves, do play with it. It's a good way of getting a feel for how things work. I might change the step size in this direction to 50, so it looks like this. Now let's have a little kind of think about why we sometimes need these kinds of loops and not repeat. I have to be honest, it took me a while to think about the best way to explain it. So I'm going to draw a picture. Imagine this is our code being executed from top to bottom. If we have a repeat instruction which calls a function with some instructions, and there's some instructions in the main code. This is the repeat. The only thing that can pass to this function is the loop counter, which might be something we call X or A or B, and at most we can pass a second one. That's the nested version of repeat. There was the version of repeat which didn't pass parameters, if you remember, which was just calling a function, say 50 times or 10 times. So those are the three versions of repeat: passing no parameters, passing one counter, or passing two counters. What if we wanted to nest deeper? So a loop within a loop within a loop. Repeat doesn't do that. There's no doubly nested repeat with three loop counters. I could have created one, but then I could have created one with 4 deep and 5 deep and 6 deep, and it would have been endless. So I didn't do that because the simplest uses of repeat were enough to get us learning about the idea of a repetition and repeating functions. So that's one reason actually we can use this new style of loop. We can nest the code as many times as we want. But there is another more powerful reason, and that is if we are working with variables like var a equals, say 3, and var b equals, say 5. When we call a function with repeat, it can't see those variables. It only knows about the variables that are passed to it. That's it. Whereas when we have a for style loop and have repeated code, it can refer to A and B because it can see them. There it is. So we can not just see variables and information that are part of the main program, we can even change them. We can say A equals A plus 5. So we can manipulate information with a loop. Harder to do that when we call a function with repeat. Not totally impossible. If you know about coding, there's something called a global variable, which are declared outside the draw function and outside the setup function. But we won't get into that today. We'll get into that a little bit in the future. So this idea of being able to see information, variables, within a loop and also change them is really powerful, and that's not something we could have done with the repeat instruction. Let's see a simple example of that working. So let's simplify this. We can say count from, we can say I, just for a counter, from 1 to 10, and we say I is increased by 100. No, it's not. Increased by 1. So we're counting from 1 all the way up to 10 in steps of 1. We might have a variable, say x equals 100. You might have a variable that's y equals, I don't know, 100 again. We could draw a circle at x and y of size 50, but in the loop we can say x equals x plus 50, and we can say y equals y plus, let me multiply it by something instead, times 1.3. Let's just give that as a go. I'm not really sure what it's going to do, but I'm hoping this illustrates the point. So inside this loop we can see x and y because they're out here, not the counter, actual variables, and we can use them like in the circle instruction, and we can manipulate them like this. Let's see what it does. Ooh, didn't Oh, I know, I made a mistake. That should have been I is less than 10. Let's try that again. There. Now, this is not a straight line. It's kind of going down, kind of like a parabola. It's like a ball falling. That was a deliberately done. Let's if I increase that by 100. You might be able to see that more clearly. So the ball is falling in a curved shape. Now that's because I'm multiplying y by a factor, so it's falling down at a faster rate, whereas x is increasing in steps. The kind of that detail of the ball's motion aside, the important point is we can see and manipulate this information, which is part of our program, inside this for loop, and that's something we couldn't do when we're using repeat to call a function. Great, we'll pause there because that's the end of another learning section about why for is sometimes needed when repeat can't help us. In this last section I'm gonna just do a little fun example just to illustrate the use of the for loop. So what I'm going to do, I'm going to go back to having a nested loop. I'm going to say x goes from, I don't know, 100 to all the way up to, I don't know, 600. To make that 200, I'm going to try and draw a grid of squares, or a square grid of spots. Let's increase that by 50, and I'll draw little circle at x and y, and I haven't got y just yet because I'm going to define the other counter. Var y equals going up from 100 to y is less than or equal to 500, y plus equals 50. See the indentation, it was helpful, wasn't it? It puts the right indentation in place. Great, so let's see what we've just written. We have a loop counter, x goes from 200 to 600, going up in steps 50. We've got another one inside that, the nested loop, which goes from 100 to 500. This one's called y, and we draw a circle. So this should end up with a grid of squares. Fantastic. No surprises there, we've done this lots of times. Now, let's nest another loop inside those, so we are 3 levels deep. So I'm just going to bring those together so they're kind of out the way a little bit. So we've got the 2 loops, one inside the other. That creates our grid. I'm going to create another for loop inside there, and let's call this, I don't know. No, let me talk about what we're trying to do. Okay, so we have a grid that's going from 200 to 600 in steps of, it's actually 50, but I'm only drawing 100 here, and so on, all the way up to there. If I did 50, they would look like that, so a lot more detailed. And what I want to do is for each one of these, so each one of these, I'm going to run another loop. So there's a loop running for every one of those spots. This is the 3rd loop inside the other 2. And this one I'm going to count around those circles. So imagine those spots. I'm going to count an angle that goes around them. So I'm going to start at angle 0 and I'm going to go up in 30-degree steps. So 30 degrees, 60, 90, all the way around. And then I'm going to draw a little circle, little spot at each of those points. Now we're going to need some trigonometry to do this, and there's a previous video on that, so I won't go into that again. But as a reminder, the coordinates, so if I had a circle and I had an angle, let's call that angle A, that spot there, the x equals the radius times cos angle, and the vertical direction is r sine angle. You can go back and have a look at those. There was a whole video on this subject. So the main point is I'm using a nested loop to go across and down the canvas, and then another loop that's inside, another level down as it were, another onion ring inside. That one will count around an imaginary circle. Let's do that. So I'm going to say for var angle equals 0. So we're starting the angle counter at 0, and we're continuing as long as the angle is less than 360. So here's an example of where there's a preference for using not equal, less than or equal to, because that might be 359. But I might choose a counter that goes up in a different way, and I might not know that it hits 359, but I always know it's going to be less than 360. So that's one example where it makes sense. And we're saying that angle increases by 30. And I need a curly bracket. Great. Just tidying up some of those spaces. So our loop repeated code goes in here. Right, phew, let's take a pause. Outer loop, loop within that. Those two go across and down the screen, and then this one is for counting around a little imaginary circle. And we can say so var, well, we can't use an x and y because we're already using x and y as variables. You can see that over here. So why don't we use x2? Var x2 is radius times cosine of the angle. What is radius? Let's just keep it, say 20 for now. Can always adjust it later. Y2 is 20 times cos angle. And we need to add those. So we're saying x plus x2 and y plus y2. Circle of size 10, little tiny circle. So what should that draw? That should draw not these dots, but little circles that go around an imaginary circle like that. Catching up? And then the next one should go around like that. That's the intention. Let's see if it does do that. Let's run the code. Ooh, I've made a mistake. I mean, it looks cool. That does look cool. But I've made a mistake somewhere. Where have I made a mistake? Ah, that's it. I didn't say sine. I had cos instead of sine. There you go. Magic. So you can see each of these positions has a ring of smaller dots. Now we couldn't have done that easily with the repeat instruction. This needed 3 layers deep, nested for loops. Now on its own that kind of looks okay, but let's kind of style it a bit. Let's use some colour. What could we do? Well, we could say don't fill it, but just use a thick outline, so no fill, and we can say stroke weight to thicken the line a little bit. Just test that works. Yep, so that's empty circles, and now we're going to choose a colour. Now what colour shall we choose? We could say stroke. We can use these counters, you know, we do have them. We can say angle divided by 2, because that goes up to 360, and we're counting in red, green, blue, which goes to 255. So I don't know, let's try that. Let's pick a number there. Let's see what effect that has. It should change the colour as it goes around that imaginary circle. Yeah, kind of. If we use HSB mode, it's easier to change colours. Colour mode, HSB. So we've got hue, saturation, brightness. So let's say saturation is 80, brightness 70. What does that do? Oh yeah, it's interesting, yeah. So we can see as it goes around the colour wheel, we get different colours. If I slow that down so it doesn't cover so much of the colour wheel, if I shift it along a bit, yeah, that's interesting. I think I'll stop there. We can carry on endlessly playing. So that's quite a nice effect. So this is not a complicated example, but it illustrates how we can use for loops which are nested 3 layers deep, and which we couldn't do with the repeat instruction. So I'll stop there. Just kind of final remarks on that, and just to kind of underline the point that I made at the start. For most of this kind of coding course, we've been using the repeat instruction because it makes repeating code really easy. And the concept of repeating code was more important than, the actual instructions for doing it. The concept of counters, loop counters, was important, and we could do that with repeat. The idea of a nested loop was also important, and we could do that with repeat. But there are some limitations, and that's the reason at this late stage I've almost begrudgingly had to cover the more complicated for loop in JavaScript. But you can see that it's not too difficult. It's not the easiest thing for complete beginners, but it's worth knowing because you'll see it in normal JavaScript everywhere and in other languages as well. So have fun with that, have a play, and in the next video we'll be back onto looking at a brand new concept again. See you next time. Bye.